In this video, you're going to study all about electrons. You will learn what electrons are, so how the electrons exist in an atom, and how the electrons participate in any chemical reaction. So this is only useful for chemistry. You know, in chemistry, you'll be dealing only with electrons and not with the nucleus of an atom. So going back to the knowledge you have from the high school, so you have been told that take any atom has got the center nucleus, which has got the protons, which are positively charged, and this is surrounded by the electrons, which are negatively charged. You also know that the number of protons are same as number of electrons because the atom is always electrically neutral. You also know the nucleus has got the neutrons, but in chemistry you will not discuss about neutrons, because only when you study physics you'll be worried about neutrons and protons. So chemistry is all about the electrons, and the nucleus is what you study in your physics. So I'm going to write this as chemistry. Okay. Now let's see what you already know about electrons. So you have been told right from your high school that you have got nucleus, and all these electrons will be revolving around this atom, around this nucleus. So if take for example from a periodic table, you know hydrogen has got one electron and one proton. Since you already know number of electrons is same as number of protons, so we're not going to discuss the protons here. Next is a helium. This has got 2 electrons, and the lithium has got 3 electrons. Likewise, oxygen has got 8 electrons, and the sodium has got 11 electrons. So the periodic table will tell you how many electrons these elements have got. Now take hydrogen. From the knowledge you already have, there is one proton in the nucleus, so the single electron will be revolving around this nucleus. If you take sodium, so sodium has got 11 protons. You've got 11 protons, and these 11 electrons will be revolving around this nucleus. So this is what you know so far from your high school studies. Now let's discuss about these electrons going round the nucleus for a while. Take the simplest atom, hydrogen. So hydrogen has got one electron. I'm going to write 1e. Now you know that this one electron is going round this nucleus. Now the type of question you can ask here is, how far from the nucleus this electron will be going round? Is it here, or is it this single electron will be this far away from nucleus, or is it the single electron will be somewhere here and going round the nucleus, or is it that the single electrons is very close to this nucleus and going very close to the nucleus? Now which of these 4 scenarios is correct? Is the electron revolving here in this orbit? I'm going to call this as orbit. This is one orbit. Is the electron going in this orbit, electron going in this orbit, or this orbit? So this is the first question you can ask is, how far from the nucleus the electron orbits. Okay. Now the second type of question you can ask is, Say for example sodium. Sodium has got 11 electrons altogether. So again, the type of question you can ask here is, there are 11 protons in nucleus and these 11 electrons. Is this 11 electrons all going together as a group? So otherwise, the one more scenario is you got a nucleus here. So out of 11, is it possible that maybe the 3 electrons are going here and the remaining 8 electrons are going in a different orbit? Now which one is right? Is it all of them going in the same orbit, or do they go in a group? Say 3 close together, close to nucleus, and the remaining 8 further from nucleus. Okay, so which one is right? Is it this or this? Now one more basic question probably now you might ask is, so we know that there is a nucleus here. Take for example a hydrogen which has got a single electron. Now if you assume that okay, this electron will go around the nucleus exactly at this distance from nucleus. Okay, this one electron goes around the nucleus. Okay, now how long can it keep on going around this nucleus? So we know that to go around or to do something, it needs energy. Now is it not possible that this electron will be going around this nucleus maybe after 1 year or after 100 circles? It will lose energy and the electron will start coming close to nucleus. So it will be, for example, it will be going maybe for 1 year it will be in this orbit. Because it is losing energy, it will, after 1 year it will be close to nucleus, it will be in this orbit. Maybe after a few years or few hundred years, this electron will be so close it will eventually collide with the nucleus. So is this possible? So if you apply the logic, theoretically it is possible, because we know that when something goes around, it always loses energy. So when something loses energy, it will go close to nucleus and it has to finally collide in the nucleus. Now these are some of the questions, okay, the scientists had a few hundred years ago, and so we are going to see now what the scientists have come up with, and that's the final, I would say the final, it's kind of a verdict made by the scientist about how the electrons are revolving around the nucleus. So finally what the scientists came up with is, so you got a nucleus here, I'm going to write that in plus. The closest orbit, scientists saw there are only 2 electrons that can go in this orbit. There's one more orbit, we call this a second orbit. So in fact they started naming this orbit as n is equal to 1, n is equal to 2. Now scientists found only 2 electrons can be going in this first orbit, and they found out if there is a second orbit, there can be 8 electrons going round the second orbit. Again, this going round is still not a valid statement, that I am going to explain in my later part of the video. But at this stage you have to understand these orbits. And they also found the third orbit, which is the number n is equal to 3. So there can be maximum number of electrons that can keep going in this third orbit is 18, and the fourth orbit, we just stick up to the fourth orbit. The fourth orbit which is further from nucleus. This is n is equal to 4. The maximum number of electrons in this fourth orbit will be 32. So instead of calling these circles as a orbit, so they named it as a shell, shell. Now this is the first shell, this is the second shell, this is the third shell, this is the fourth shell. So what the scientists have come up with is, the very first shell, the scientists saw 2 electrons are going around. The second shell, they are able to see 8 electrons, maximum 8 electrons that will be going around. And the third shell, there will be 18 electrons. And the fourth shell, there will be 32 maximum electrons. Again, this is the maximum number, because number of electrons depends on the element. Say for example, hydrogen. Hydrogen has got only 1 electron. So that one single electron will be somewhere here in this orbit. Now you might ask one more question at this stage. Is the electron going clockwise or anti-clockwise? So the best answer at this stage is, first of all, electrons do not go in circles. So because they don't go in circles, there is no question whether it's going clockwise or anti-clockwise. So, but later on, we'll come to know exactly how these electrons will be around the nucleus. So you can use this model to understand how the electrons are distributed. So take helium. Helium has got 2 electrons. The electrons will start filling from the innermost circle. Now you know that in the very first shell, that can be a maximum of 2 electrons. So both the helium electrons will be here. So for helium, both the electrons will be here. Now take lithium. Lithium has got 3 electrons. In the case of lithium, out of 3 electrons, the first 2 will be here. So out of 3, 2 will be here. The next one, remaining one, will be in the next orbit. So in lithium, 2 will be in shell 1, and the third one will be in shell 2. So we're going to use this diagram to study electrons for a few elements from periodic table. So what I remember at this stage is, the innermost shell, that's in the red color, there can be a maximum of 2 electrons, and the second shell, the blue color, you can have a maximum of 8 electrons, and the third shell, so I'm going to put this as or put it another way. So write this as a shell 1 can have a maximum of 2 electrons. Shell 2 can have a maximum of 6 electrons. So you can write 6 followed by letter E. And shell 3 can have a maximum of 18 electrons. And shell 4 can have a maximum of 32 electrons. Okay, these things to remember. Now we have seen up to lithium so far. Take the beryllium, which is Be. So beryllium has got 4 electrons. So now you just have to start filling this inner circles to its maximum capacity. So out of this 4 electrons, so 2 will be in the first shell, and the remaining 2 will be in the second shell. Now I'm going to undo this thing so you can try the next element. Next is boron. So boron has got 5 electrons. So the first 2 electrons will be in the inner shell, because inner shell can have a maximum of 2 electrons, you know that. The remaining 3 electrons will fill in the second shell. Next we are going to see about the carbon. So I'm going to undo. So carbon has got 6 electrons. The first 2 will be here and the remaining 4 will be here. At this stage you have to start using a terminology called outer shell. Outer shell. Say for example in a carbon, to fill 6 electrons, carbon requires shell number 1 and shell number 2. You can say that the inner shell is always 1, but the outer shell means the remaining 4 electrons, so that occupies a shell, so that's called as the outer shell. So the outer shell for carbon will be n is equal to 2. The second shell is the outer shell. For example, for hydrogen, so go back to hydrogen. Now hydrogen has got only 1 electron, so 1 electron fills here. So for hydrogen, the outer shell is the first shell. For lithium, which has got 3 electrons, the first 2 electrons will go here, the third electron will go here. So the outer shell for lithium is shell number 2. So depending on the number of electrons, the outer shell will change. So let's take sodium. Sodium has got 11 electrons. So this is just a simple a math problem. So in order to show the electrons, how the electrons go around this nucleus into various shells, you just have to start splitting these 11 electrons into various shells. So the first shell to fill is the innermost shell. So the 2 electrons will go there. So you got 2 away. You got 9 left. You know that second shell can have a maximum of 6 electrons. So out of this 2 will be going in the inner circle. 6 will be going in the second shell. So when you take away 6, you're left with 3. And the remaining 3 will be revolving around this third shell. Again, I've been using this word revolve. And keep in mind, electrons do not revolve. So our main objective here is to understand this concept of a shell. So once we are good in this shell concept, we'll not start using this word revolve after that point onwards. Now, so by the time you fill all the 11 electrons, so we have got the outer shell for this sodium is shell number 3. So you can also keep on applying this for, let's take an example of aluminium. So aluminium has got 27 electrons. So I'm going to undo this. Okay, so aluminium has got 27, sorry, aluminum 13. So let's take something more than 13 electrons. So we'll go with, say, copper. Okay, so copper has got 29 electrons and 29 protons. So our job is now to split this number 29 into various orbits. So the first 2 will go to inner shell. So if you take away 2, you're left with 27. And the second shell can hold a maximum of 6 electrons. So you can put 6 electrons there. So out of 27, take away 6, you're left with 21. The third shell takes 18 electrons maximum. So 18 electrons of copper will be in the third shell. So you can fill this with 18. Okay. If you take away 18, you're left with 3. So these 3 electrons has to go into this fourth shell. The fourth shell can go up to 32 electrons. So the fourth shell will have the remaining 3 electrons. Now in this scenario, the outer shell is for Likewise, so how many electrons can we put maximum in this 4 shell structure? If you add up all this number 2, 6, 8 and 32, 18 and 32, so you'll have 10, 16, 18 and 58. So using 4 shells you can put 58 electrons. If you look the periodic table, the element with the 58 electrons is cerium, Ce, cerium. Okay. So next we are going to ask the same question, okay, we asked at the beginning of this video. So we are going to take this example of sodium again. It has got 11 electrons, and we know how these 11 electrons are distributed around this nucleus. We got 2 here, and we got 6 here, and we got the remaining 3 here. So I'm going to put this as a cross. Okay, let's ask the same question here also. Now you know that, take for example the second shell, the green one. We know in case of a sodium there are 6 electrons in this shell. Now the question is, do all these 6 electrons go together? Do they always go in a group, or do they go in a combination of the first electrons 1 here and 3 there and remaining 2 there? So this is the question you're going to answer now. The same question you can ask for any of these shells. What about the very first shell? Does these 2 electrons go together, or do they go one behind the other? See, now so far what we understood is these 2 electrons, they move in this circle. These 6 electrons in the second shell, they go in this circle. We still don't know, okay, how do they go? Do they go all together, or is it possible that they divide between equally between them? So 3 will be in one group, the remaining 3 is in another group. So these are the questions, okay, the scientists have answered for these questions. The same thing applies even for the fourth shell. So we know that the fourth shell can have maximum for 32 electrons. So how do these 32 electrons go? Do they all go together, or do they all go in a group? So what you're going to learn next is, so we are going to subdivide, you're going to again zoom this thing out, zoom in and say how exactly, what exactly this orbit is made of, what exactly shell is made of. That's what next thing you're going to discuss. So far what we know is, around this nucleus there are shells, and these shells are certain distance away from the nucleus. The first shell is near to nucleus, then the second shell, then the third shell, and the furthest is the fourth shell. You can have a fifth shell, sixth and seventh and so on. Now what scientists have found out, these shells are made up of something else, and that is called as the orbitals. So you can say that the shell is made of orbitals. Now the innermost shell, that is the shell number 1, is made of just one orbital, and in this one orbital these 2 electrons will be moving together, and they are also given a name for this orbital. So the only orbital that is in shell number 1 is called the orbital S, or S orbital. Now remember, this orbital, S orbital, can have only 2 electrons maximum. Then what the scientists have found is, they looked into what is the shell number the second shell is made up of. Now the scientists saw the second shell has got 2 orbitals inside. The first orbital is called S orbital, which can have 2 electrons, and the second orbital is called as the p orbital, which can have maximum again 6 electrons. Now we already know the maximum electrons in shell number 2 is 8. So when you add up the number of electrons in these orbitals, you have to get 8 electrons. So keep in mind again. So the second shell is made up of 2 orbitals. Some book also call orbital as a subshell, but this orbital is more often used, but you can also use subshell. So a shell is made of a subshell, or you can say a shell is made up of orbitals. The second shell, there are 2 orbitals. The first orbital, the one I marked in red, is called s orbital. So 2 electrons can go maximum. The second orbital is called a p orbital. So there are, the maximum is 6 electrons. So likewise, the third shell has got 3 orbitals. The name of these orbitals are s, p and d. You already know s and p from shell number 2. It's exactly the same structure. The s orbital, remember one thing here, the third shell has got 3 orbitals. You can also try to relate the number of shells with the number of orbitals, and this applies only up to the shell number 4. You can say that first shell has got 1 orbital, second shell has got 2 orbitals, third shell has got 3 orbitals, fourth shell has got 4 orbitals. You cannot apply this easy definition for shell number 5, but at your level you won't be going more than 4 shell. So the third shell has got 3 orbitals. They are s orbital, p orbital, d orbital. In s orbital there are 2 electrons maximum. In p orbital there are 6 electrons maximum, and d orbital there are 10 electrons maximum, 10 electrons. Now we also know that the maximum number of electrons in shell number 3 is 18. So when you add up all these number, 10 plus 6 plus 2, you get 18. Next is the fourth shell. The fourth shell is made up of 4 orbitals, s, p, d and f. So the s orbital can have maximum 2 electrons, the p can have 6 electrons, the d can have 10 electrons. That's exactly what you learned in shell number 3. The fourth orbital is called f orbital. So it can have a maximum of, sorry, it's not 10, it is 14. The maximum 14 electrons here. So when you add up all this together, you'll end up getting 32 electrons in shell number 4. So just summarize what we discussed so far is, we just found out that the shells are made of subshells, or one more name for that is called orbitals. The first shell has got 1 orbital, and also each orbital is given a name called s orbital. And the second one is the shell 2 has got 2 orbitals, s, which can have maximum 2 electrons, and p, which can have maximum 6 electrons. And the third shell has got 3 orbitals, that is s, p, d. S can have 2, p can have 6, which is same as shell 2, and the d orbital has got 10 electrons maximum. Similarly, the fourth shell has got s, p, d, f orbitals. So the s can have 2, p can have 6 maximum, d can have 10 maximum, f can have 14 maximum. So the one more thing you have to keep in mind is, so you have to know which orbital is close to the nucleus. So I'm going to put a plus sign here to show the nucleus. If you look at this shell number 1 is very easy because it has got 1 orbital, s orbital, which is the closest to the nucleus. Shell number 2 has got 2 orbitals. the s orbital is close to nucleus, then after that comes the p orbital. In shell number 3, the s is close to the nucleus, then closest is d, then closest is, sorry, the first is s, afterwards p is closest to the nucleus, and after that d is closest to nucleus. In case of the fourth shell, the s is close. So always remember the s orbital is always closest to the nucleus, then the p is the second closest, then is the d, and further is the f shell. But there is an anomaly here which I am going to tell in later part of the video. So you just have to keep in mind these things so far. So now we are going to fill the electrons using this sp, d and f orbitals. So I've got on the left hand side the simple model where I'm showing only the shells, shell 1, 2, 3, 4, and the right hand side I'm showing the subshells or the orbitals. So we'll take the simplest example is the hydrogen. So hydrogen has got 1 electrons. Now we know how to draw that, how to show 1 electrons here. So 1 electrons will be here in this shell number 1. Whereas here the same 1 electrons, you have to say that it is in the s orbital of the first shell, shell number 1. Now keep in mind the knowledge you have got so far is in shell 1 you got s orbital, in shell 2 and maximum 2 electrons, and in shell 2 you got s and p, and in the shell number 3 you got s, p and d, and you got shell number 4 you got s, p, d and f. And you also know that in all the s orbital there are 2 electrons maximum, in p orbital there are 6 maximum, and in d the maximum is 10 electrons in d, and in f the maximum 14 electrons altogether. So this you have to remember. So take helium. So helium has got 2 electrons. So here the way you show here is you just show the 2 electrons in the first shell, whereas here even though the first shell has got 1 orbital so when you start speaking about SPDF, so you just have to use this word s, don't use the word shell. So here the 2 electrons will be in the s orbital. Take lithium. Lithium has got 3 electrons. Now the way you show here is you show 2 in the first shell and the third in the second shell. When it comes to the SPDF model, 2 will be in the s orbital of the first shell. Now next is you have to go to second shell. In the second shell I mentioned that the s orbital in the second shell, the green one here. So in the second shell you got s orbital and you got a p orbital. When you start filling electrons, you have to first fill the innermost or the orbital that's closest to the nucleus. Only when that orbital is full you can go to the next orbital. So here I got the third electron will go in here in the s orbital of the second shell. Remember the s orbital of the first shell is already full because an orbital, s orbital can have a maximum of 2 electrons that's full. The third electron lithium will go in the s orbital of the second shell. Now after lithium you got beryllium, which is number of electrons 4. You just have to the s orbital. So the 2 will go in the first shell s orbital. The remaining 2 has to go in the s orbital of the second shell. The way you show it is you just put to show 2 electrons in the shell number 2. So next is boron, which is 5. The way you show here is you already have 4 here. I can put one more 5 because the second shell can have a maximum of 8. You know that. Here in SPDF model, the third shell, sorry, the third electrons, the fifth electrons, you already got 2 here. You already got 2 in the s shell. Remember s orbital, sorry, s orbital not shell. The s orbital can have maximum of 2 electrons. So the fifth electron has to go in p. So next is the carbon, which has got 6 electrons. So here you show this the next electrons in the second shell, whereas here the next electron will be in the p orbital of the second shell. So it is a p orbital of shell number 2. So you have to also start practicing how to write this this sentence, okay, in a simple notation. So the p orbital of shell 2, so that is, this is the way you write the p orbital of shell 2, or the s orbital of shell 3, or the p orbital of shell 3, or the d orbital of shell 4, or the f orbital of shell 4, or the d orbital of shell 3, and the d orbital of shell 2. So this is wrong, because shell 2 has got only 2 orbitals, the s and p orbitals. So there is no d orbital, so you have to be careful here. So you can just keep on continuing like this. So I'll take one more example. So that will be, okay, take an example of phosphorus. So phosphorus has got 15 electrons. The way you fill in this old model is, you'll have 2 electrons here, you'll have the 8 electrons here, you've got 8 here, so out of 10, remaining 5 will go here. Now when it comes to SPDF model, we'll have 2 electrons here, so we are done with this one. And the second shell has got 8 electrons, but we know second shell is made of s and p orbital, where s can have 2 and p can have 6. Okay, so we are done with the second. So already we have got 8 we have put altogether, 10 electrons we have put, so we have got 5 remaining. So remaining 5 will go here. Remaining 5 here. Okay, so in the third shell, the third shell has got 3 orbitals, s, p, d, f. First 2 will go to s, the remaining 3 will go to p orbital. Okay, so this is how you fill the electrons using SPDF. So next you are going to see that again we have got 6 electrons in this, say for example here in the p orbital 6 electrons. You can ask the same question: does all the 6 electrons do they go together, or do they go in a batch of 2 or 3? So now we are going to again see what exactly this p orbital is made of. So far what we know is, the shell number 2, shell number 3, shell number 4, we know all these 3 shells, they have got p orbitals, and you also know that the p orbital, there are maximum 6 electrons. So what scientists came to know is, this p orbital is made up of, actually is not just a single p orbital, there are 3 orbitals. So they are named as a px, py and pz. So these names they come from your geometry x, y and z axis. Okay, so keep in mind there are 3 p orbitals. So this is how you have to mention about the p orbitals. So each p orbital can have a maximum of 2 electrons. So you got a px 2 electrons, py 2 electrons and pz 2 electrons. So all put together we can say that the p orbital can have a maximum of 6 electrons. In fact, there are 3 p orbitals. So there are 3 p orbitals in shell number 2. There are 3 p orbitals in shell number 3. There are 3 p orbitals in shell number 4. And p orbitals, and each of these p orbitals can have a maximum of 2 electrons. In some textbooks, they show these orbitals as a square box like this way. So they say this is a px, and this one is a py, and this is a pz. So as long as you name them correctly, so people understand that you are referring to the p orbitals. The next is, we also know that the d orbital can have a maximum of 10 electrons. So what the scientists came to know is, it's just not one single d orbital having all the 10 electrons. They found out there are 5 orbitals, and all these 5 orbitals put together they are called d orbitals. So you can also say that there are 5 d orbitals, and each orbital can have a maximum of 2 electrons. It doesn't matter whether the orbital is s orbital or one of the p orbital or one of the d orbital. So each orbital can have a maximum 2 electrons. So as you can see here, so there are 5 d orbitals in shell number 3. There are 5 d orbitals in shell number 4, and all put together a d orbital can have 10 electrons. However, each d orbital can have a 2 electrons each. So all put together get 10 electrons. So as I mentioned before, some books they show this orbital as a square. So you can have a maximum for 2 electrons here, 2 electrons here, 2 here, 2 here, and 2 here. So likewise, the scientists came to know that there are 7 orbitals in the f orbital. So it's not one single f orbital. There are 7, you can call 7 f orbital for the time being. So, each orbital can have a maximum of 2 electrons. So altogether we know that in f orbital there are 14 electrons maximum, and these 14 electrons are made up of 2 electrons in each orbital. So there are 7 f orbitals, and the f orbital is present only in in shell number 4 onwards, shell 4, 5, 6, 7, so on. Okay. So in some books, you can see 7 squares, and each square is a single orbital, and a single orbital can have maximum 2 electrons. Now at this stage, you should also know how the electrons are shown in orbital. So we don't draw this line and show 2 electrons like this way, or 1 electron like this. We don't do that. So when you show the electrons inside an orbital, so the first thing what you have to do is you have to draw an orbital. So you don't have to draw this curved line. Just draw a square like this way. And if there is only 1 electron, you can show that electron as an up arrow, or you can also show a down arrow. Whichever way, it doesn't matter whether you show up arrow or down arrow. If an orbital has got 2 electrons, then the other electron you always show in a reverse direction. So if you started with the up arrow as the first electron, then the second electron, if it is present, shows a down arrow. Or if you started the first electron by showing in a down arrow, the second electron you can show that as an up arrow. Now next we are going to practice how to write the electron structure using orbitals, but this time we are not going to draw the nucleus and all these circles. Instead we are going to use these squares. Now what you got here is, you have to first understand what this diagram is. So I have got the shell and the orbitals. For the first shell there is only one orbital, that s orbital, we know that. Remember, each orbital can have maximum 2 electrons. For the second shell, you got 2 orbitals, that is s and p. We know there are 3 p orbitals, px, py, pz. Now for the third shell, you got 3 orbitals called spd. You got 1s, 3 p orbitals, and you got 5 d orbitals. Now if you want to start learning, try with the simplest one, the hydrogen. Now hydrogen has got 1 electrons, so that will be, you always start filling from the shell 1, and the nearest orbital is s, shell 2 s and p, because if you want to visualize that, this is a nucleus, the s orbital is first and the s orbital of second shell is first, then comes the p orbital. This for the shell 2. For shell 3, the s comes first, then p comes second, afterwards it's a d, spd. So you have to start filling the shell that is near to the nucleus. So for hydrogen, so H is equal to 1. So I'm going to write the first shell like so, an arrow, up arrow. Now for helium, helium has got 2 electrons. So you already have 1 for hydrogen. So you know that the s orbital can take 1 more electrons too. So this is what you have done it. This is what the correct way to write for helium. Next is lithium. Lithium has got 3 electrons. 2 we already got. Then 1 will go into the next cell up. Then comes the beryllium, which has got 4 electrons. Now so far you already got up to lithium. The 4th electron will go. Remember, if you write like this way, this is wrong. So when an orbital has got 2 electrons, you have to show in different directions. So in other way, now you have to, these arrows indicate the spin of an electron. So 2 electron in a shell, they can reside only when one is turning in clockwise, the other one is turning anti-clockwise. Just to keep everything in a neutral, because atom it's in neutral state always. So next is your boron. So boron has got 5 electrons. It's very easy to start filling this. So this is full, we can't do anything here. We have to fill here, so 1 electron go up. Then you have to start, there's something new you're going to learn from this point onwards, okay. Now after this beryllium, you got boron, which is 5, sorry, carbon is 6, okay. Now 6, okay, where do this next electron go? Will it go here or will it go here? So the way the electron will always try to go is, it always try to be far from any other electrons. Now in this p orbital, the first orbital has got 1, and p1 and pz there is no electron. So what happens in case of carbon? The 6th electron will go to the next shell. It will never go to the px, because px already has got electron. Just start saying that because px already got electron, it will repel. So to avoid that, the 6th electron of carbon will occupy a empty orbital. Next is the nitrogen has got 7. Again, the next electron will not go here or here. It will always, first it will give a chance, it will see, oh, is there any free orbital? Yes, it will always go there. Next, after nitrogen, oxygen has got 8. Now all these 3 orbitals, they all got single electrons. The only way for this 8th electron to go is to occupy this one, 8th electron. Next is the fluorine, which is 9. So the 9th electron will go here in the next py. Next is the neon. Neon has got 10 electrons, so that electron will go here. So now we have got the shell number 2 is full. All the 4 orbitals have got 2 electrons each. So altogether got 8 electrons. Next comes the sodium. Sodium is 11. So this is full, you got 2, this is full 8. The 11th electron will occupy this one. Then is magnesium. So magnesium is 12. So next electron will go here. Remember, it cannot go to p orbital until unless the s orbital is full. Now next is aluminum. So aluminum is 13. The next electron will go here. After that is silicon. Silicon is 14. See, now there are 3 p orbitals. Remember, electron will always try to first occupy empty orbital. So the electron of silicon will go here. Next is phosphorus, which is 15. The next electron will go here. Now remember, this is sorry, not that. Okay, yeah. So only after all the p orbital is full, we can go to the d orbital. So then is sulfur, which has got 16 electrons. The next electron will start filling this up. After that, chlorine. Chlorine has got 17 electrons. That will go here. After that, argon has got 18 electrons. So that will go here. So now the p orbital is full. So you got 2 electrons here. You got 6 electrons here. After argon comes the potassium K, which is 19 electrons. So that will go to the D here. So potassium will go there. Then calcium will go here next. And afterwards you'll have scandium will go there. And this is a titanium is 22 goes here. And vanadium will go here. Now all these 5 orbitals have got 1 each. Then chromium will go here. And next one will go here. So this will continue, okay. Now whatever we discussed so far up to here is right. So after this the p orbital of shell 3, once all these things are full, it doesn't go to the d. It will go to the s orbital of the 4th shell. So this is what you're going to learn in the next video.